So today we're looking at section 7.2, which is on exponential decay. This one is going to go a lot faster since everything we're doing is a replica of what we had yesterday with exponential growth, except instead of our equations being slow rising up, they're going to drop fast. They're going to start high and then drop. The equation we're going to use for exponential decay is still the same, y equals a times b to the x, except this time your b value is going to be fractional. It's going to be a number between 0 and 1. So that's the clue to look for to decide if it's growth or decay. Do you have a whole number for b, like 2 to the x, or do you have a fraction for b, like 1/2 to the x? Today we're looking at fractions. The word problems we're going to change. Instead of 1 plus the rate, since it's decay means it's getting smaller, we're going to do 1 minus. We'll do 1 minus the rate when we write our equations. We will still have a as our initial amount. We'll have an r value, a percent value for a decay. Remember to change that into a decimal. And then t will stand for time. Our equation that we're going to graph will still have those same a, h, and k values. Our go-to points will be the same thing, 0, 1 all the time, and then 1b. And your b value will be the number that you're going to pull out of your model. The domain, again, is all real values. Your range will be that k number sitting in the back, just like we had yesterday. K number from the back will give you two answers. It will give you the range, and it will tell you where your asymptote line is. Now, if you can remember yesterday, your picture of your graphs were slow rising up. Now they're going to start high and drop and approach that asymptote line. Couple samples. Y equals 1/5 raised to the x. This one does not have any shifts. There's no number next to the x. There's no a value in the front. There's no k value in the back. Since I have 0 in the k value, I can answer these two questions right away. My range is all values greater than 0. My asymptote line is at 0. And then I can do my go-to points. The first one is always 0, 1. The second one is 1b. Since our base value is 1/5, I do 1/5. And I can plot those. 0, 1, 1, 1/5. Now with these points, sometimes you're going to have to estimate where about is 1/5. Very low on your graph. Remember, they start high. Pick up your two dots and then approach your asymptote line. Make sure it doesn't cross over that asymptote line. Domain, all real values. Next one, -2 times 3/4 raised to the x plus nothing. No k value in the back, and I don't have an x value that I'm adding in as well. I just have a value, multiplier. My go-to points are 0, 1, 1 3/4. Since I do not have anything next to the x, I will not change my x coordinate. 0 stays 0, 1 stays 1. Now I have my stretch number in the front, that's my multiplier. -2 times the y value times -2 with the y number. 1 times -2 is -2. 3/4 times -2 is -6/4. Same thing as -3/2, -1.5, and I can plot them. 0, -2. 1, -1.5 is about here. Now this one, since our usual decay graph starts high and goes low, notice on this one we had that negative sign in the front. Negative sign means flip. So I'm taking this entire graph and I'm flipping it upside down, which gives me that mirror image. That's why this one is facing this goofy direction here. So it starts on the bottom end, picks up my two dots, and approaches the asymptote line. Asymptote line was 0. And since this one flipped underneath, my range, be very careful with this now, my range is underneath the asymptote line, which it means it is less than 0. Y is all values less than 0. And then the domain is all reals. Okay, we're going to skip this one and we're going to go right to this one. This has all the shifts in it. Y equals 5, 2/3 raised to the x plus 1, and then subtract 2. So I have all shifts, A, H, K. my go-to points, 0, 1, 1 comma, 2/3. What is your x value going to change to? It says plus 1, we subtract 1. 0 minus 1, 1 minus 1. X values are done. Y value. Start with multiplying by 5. 1 times 5, and then I have to subtract 2. So 1 times 5 is 5, 5 minus 2, 3. 2/3 times 5, y value, 2/3 times 5. If you're not sure what you're doing, write it down. 2/3 times 5, 10/3. Then I have to subtract 2. Well, let's look at it. 2/3 subtract, or 10/3 subtract 2. 2 is the same as 6/3. Then you can subtract 4/3. Those are my two ending go-to points. -1, 3, 0, comma, 4/3, which is about 1 1/3. I don't know, something like right there. Asymptote line. In the back, -2. Y equals -2. That's also going to be my range. Y is greater than -2. Domain, all reals. -2 is my asymptote line. This one starts high, there's no flip on it. Starts high, approaches my line, not crossing. There you go. So the most fun thing that I like to cook, or my favorite thing to cook, is lasagna with Italian sausage. The word problem for exponential decay is going to be the same as what we had for exponential growth. One difference is that we subtract the rate instead of add the rate. B, again, this is our B value, this stuff in the parentheses, that's the B value. It's called a decay factor. Just like yesterday, it was called a growth factor. 1 minus the rate. Make sure you change your rate 2 decimal places, point something something for your rate. T refers to time. All right, so I'm going to talk you through a word problem here. I'm also going to show you how you can do some of this on your graphing calculator. So have your graphing calculator handy, and I'll talk you through some steps. We want to buy a new snowmobile that costs $4,200. The value decreases, oops, I need a D there, decreases by 10% each year. 10%, what's that look like as a decimal? Write the model. When you write your model, make sure you have y and x, or t, in it. You have to have y and x in your model. Starting value, and if you need the form again, y equals a, 1 minus r raised to the t. A value, $4,200. 1 minus 0.10 raised to the t. This is fine. If you wanted to go ahead and do this subtraction, that's okay too. Y equals 4,200 times 0.9 raised to the t. Those are things that I need to see when you write a model. A y value and a t value, and then your start number, and then whatever we're going to have as our multiplier. Part B. How much is it worth after 3 years? In place of t, we're going to put our 3. 4,200 times 0.9 raised to the 3. Punch that in your calculator and you'll see that it's worth this. Part C. Use your calculator to see when it is worth 2,500. So now I'm looking at my equation, my original model, which would be this one right here. I'm looking at this model and I want to find out how much time does it take, how much time does it take for this to be worth 2,500. So I'm trying to solve this equation. 2,500 equals 4,200 times 0.9 raised to the t. But we don't know how to get t away from being in the power position. That's logarithms, and that's what we do next. So for now, when we're being asked to solve this question, we're going to use our calculator to help us. So here's the process we're going to do to get that on our calculator. What I want you to do is go to your y equals screen, and I'll bring my calculator up in a second. So these are just our steps. We're going to go to our y equals screen, and we're going to type 2 equations. The first equation is the model that we wrote, and the second equation is what we want that model to be equal to when we're done. 2,500. Then we have to go to our window, and we need to be able to have a window set to be able to see this information. Once we have the window set, then we can calculate the intersection spot of these two lines. Okay, so we're going to enter the information into Y1 and Y2. We're going to reset our window, which we have to do every time we do a word problem, and then we'll calculate the intersect spot using our calculator. All right, so grab your calculator. Okay, there's mine. Grab your calculator. We're going to go to the Y equals button. Y equals button is up on the top left, so hit your Y equals button. We're going to now type our equations. So the first equation was 4,200 times 0.9 raised to the x. That's the first equation. 4,200 times 0.9 to the x. Now, arrow down one spot so you're in Y2, and now we're going to type the other number that we want this object to be worth, which was $2,500. So they were asking us how much time does it take for this original price to drop from 4,200 down to 2,500. So we have our equation set. Now we have to go to our window. So up on the top line again, go to your window button, which is on the second left. You get a screen that looks like this. Now typically we've been doing zoom 6. Zoom 6 gives us these standard numbers from -10 to 10 in both directions. Well, that's not going to allow me to see this picture because remember this object started at, what was it, $4,200? Well, 4,200 is obviously not 10. Okay, so I need to get these numbers higher so I can see the stuff that I'm looking for that relate to this problem. All right, now your x value refers to time. Time doesn't need to be negative, so I can have my minimum x value start at 0. So just type a 0 on top of where that blinker is, and that's our minimum number. Now the x maximum is our guess. How much time do we think this is going to happen? Well, for right now, I have absolutely no idea, so I'm just going to arrow down. We're going to leave it set at 10. Maybe it's going to take 10 years. We have no idea. Maybe it's going to take 20 years. We'll be able to tell that once we hit the graph button and see if we've gone out far enough. So for now, we're going to leave it at 10. SCL refers to scale. How do you want to count by? Well, from 0 to 10, those numbers are really close. I could count by ones. That's perfectly fine. So let's tab down to the Y value. Y minimum. This is the value of the money of the object. Well, it can't get any lower than 0, so I can have this minimum be 0. And then the maximum, we can put in the actual starting number of this object, which was 4,200. So now I'm going to have a window that's going to start at 4,200, stop at 0, because it can't be a negative value, and my time, which is 10 years, stopping at 0, because it can't have a negative time. Arrow down one more, though, to where your Y scale is. I have a big jump of values here between 0 and 4,200. So we want to make sure we count by something big. I'm just going to change that to 500. So the calculator is actually doing tick marks, counting by 500 in there. And then it'll be a little easier for the calculator to figure out how to graph this. All right, so we have our window set. We're fine. Go ahead and hit your graph button. Upper top line, far right side. You're now getting two things that are going to be drawn in. The first one was the curve, the exponential decay curve, that 4,200 times 0.9 to the x. The red line for me that came up here is the straight line at 2,500. These two things crossed. That's what I wanted to happen because now I need to find that spot right there. If this would have taken longer than 10 years, then these two lines wouldn't cross. I wouldn't be able to see them. So I'd have to extend my window out farther to maybe say 20 years to be able to see it. But I can see this, so it's okay. So now what you're going to do is calculate the intersect. So if you can remember, up on the top line above the word trace in blue, for me, it says calc. I need to go there. Second, calculate. Choice number 5 is intersect. So hit choice number 5. And now you get, I'm going to erase my little green circle there. Now you get a little blinker in the middle of it, and it's asking you, do you want me, with question mark, do you want me to look at my first curve, question mark? Yes, we do. Just hit enter. Now it changes to second curve, so it's asking, so you want me to find the intersection of the first curve with that second curve? Yes, we do. Hit enter again, and now it's going to guess that intersect spot for you. Yes, we want it to do that. Hit enter a third time. So when you do this second calculate and take choice 5, which is intersect, just hit enter, bing, 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 3 times, and you will come up with the exact intersect spot for how much time it takes. So this thing is worth $2,500 after 4.92 years. Now I do not want you to round that number. Let me go back to my screen now. Do not round that number. 4.92 years, I want you to leave it like that. Don't put 5. Put the decimal value that you see on your calculator screen. Then I know that you're calculating this intersect spot correctly. Okay, so there you go. There's exponential decay with a little bit of calculator help to try to find some stuff. Please now go to Skyward and do your Skyward Online 3 questions, and we'll see you tomorrow.